just by practicing those step functions that we talked about, which is a type of piecewise function. And so we're going to go ahead and graph that up here. We're going to do that in pieces. Let's have, what up? You can bring your paper up if you'd like. I'm not trying to scare you. Now listen carefully. I need you to draw one of the pieces on there out of the three. Not all three, just one. Make sense? Okay. So we're having her put one of the pieces on. And then she's going to randomly pick one of you in the audience to put another piece on. And then they are going to pick one of you in the audience to put the final piece on. Wonderful, hands it off. If for some reason you are still struggling on this, I would be happy to work with you any day during homeroom or any day after school till 3 o'clock except Monday, because we have faculty meeting Monday. Okay, so please just schedule a time with me before Thursday on the chapter test when you have to do this, and there'll be probably like 15 to 20% of the chapter test. So I don't want you to lose out and get a bad grade based on these types of problems. Okay? And you've got lots of opportunity to make sure you understand it. All right. Any questions? No. Lovely. Okay, hand those papers at this time to your gopher. And gopher, we're going to collect that lovely essential work and put it in the black tray. So I just handed out graph paper to most of the groups. Make sure you separate it so each person gets part of that. And then at the top of a clean sheet of graph paper, we're going to take some notes. And it's on graphing absolute value equations. Since I gave you graph paper, we're going to be graphing. Right here, I've given you three things that are going to be very helpful in graphing absolute value equations. Now, I will admit to you right now, piecewise functions, that's what you've been working on for the past 3 days, right? Is one of the hardest topics in Algebra 2. And I think that after working so hard for almost an entire week on one topic, I think it's Friday, we need to do an easy topic. What do you guys think?
Yeah.
Lovely. Absolute value graphs are actually very simple. And after today, you will be able to complete the chapter review. How's that sound? Very good. Lovely. All right. So right here is the basic equation of an absolute value graph, or an absolute value equation, where A is the slope, and H and K is the vertex. Now, the reason I give you that, or show you that, is because on state tests, sometimes they like to give you formulas, and that would be the formula they would give you. Okay? But if you're actually able to apply it and know what these things are by the end of the period, then I'm quite happy. You don't have to memorize this formula, but it will be helpful, at least if you see it today, to then know when you take a college algebra course and you see it again, you're like, oh, okay, I've seen that formula, it's not so scary. All right. Well, instead of us going straight to graphing and me just saying, okay, here's how you do it, we're going to make some observations, and we're going to use our graphing calculator to do that. So you do need your graphing calculator today. And you don't need to write this part down, because you're going to observe, okay? So here I have 4 equations. And notice it's 1 absolute value of x, 2, 3, 4. Do you think you can keep those in your mind for a memory for a few minutes? Good. Because now they're gone. Because I need my calculator up too, right? So I'm going to clear anything on my regular home screen. That was mainly Algebra 3 that we were doing. And now I'm going to go to my y equals. And if there's anything in there, go ahead and clear out everything that's in there. And then go back up to y1. Because I want to show you how to put those absolute values in your distance. calculator. Now, what you do first is you go to Math, over to Num, and the very top one, ABS, actually is absolute value. So I'm going to click enter. Notice once I click enter, it makes the straight lines, right?
Yep.
Okay, I'm going to type in the letter X, that's this key right here, now in red for you. And that little arrow is in case I want to type anything else inside the absolute value sign. If I needed to go outside, I'd have to hit that little arrow. I'd have to hit the over key so it knows to be on the outside. But that's all the further we're going to do with that one to start. We're not going to hit graph or anything yet. We're just going to wait. But before I move on, raise your hand if you have a calculator at home that graphs for you. Okay. Sammy, I saw yours, right? Okay. So Sammy, yours is going to look exactly like mine. Raise your hand again. Oh wait, we've got a lot of you. Okay, hold up. Let's do this. Raise your hand if you have the TI-84. Okay, if you have the TI-84, tonight go home and try this and see what pops up whenever you do it. See if the lines pop up or the letters ABS pop up. If the letters ABS pop up, bring your calculator to school and we're going to try to fix it so that it does this now. Kind of like the old iPhones, you have to update them every so often, right? Same thing with calculators. Raise your hand if you have the TI-83. Okay. Raise your hand if you downloaded my calculator instead. Okay, so both of you, when you click on my ABS, same way, same process. You're going to see the letters ABS parentheses. Whatever you put in parentheses, it's like whatever you put in these. It doesn't do this part, okay? It won't update to make that happen. I don't know how to do that yet. If I learn how to do that, I will show you so you can fix it. Sound good? Okay. Any questions? Yours does? Okay, so I'm going to update it for today. How about just grab a different one then? And then throw that one on my desk. I'll play with it next period. All right, so now we're going to type in 2 times the absolute value of X. So that's 2, Math, over to Num again, ABS. Go ahead and just grab a different one for today, Katie. What number is yours? Huh. Interesting. 28 and 26. All right, throw yours on my desk, Katie. No problem. X. They still work the same way, but I just want to fix them so that they're updated to my standards. Go ahead and if you can at this time, do the rest of them. 3 and 4. 3, Math, Num, enter, X, down. 4, Math, Num, enter, X, down. After a while, you start getting good at it, right? Now, today in my earlier classes, I actually heard a few people say, I don't like these graphing calculators. Because they're new and they were having trouble knowing exactly where to go, right? But I explained to them, if you go and get a job, is your boss going to say, do all these calculations by hand, or do all these calculations correctly? Yeah, they're going to go with the correctly, and they're going to assume or hope that you use what? A calculator. So I try to get you introduced to them now. Now don't hit graph, just look up at mine for now. I'm going to hit graph, and here's my first graph. There's the regular absolute value of X. And now here comes 2 times the absolute value of X. And now here comes 3 absolute value of X. And now here comes 4 absolute value of X. I know how long to pause even, isn't it amazing? So I want you to talk to your group real quick. What's happening? What's happening? Talk to your group. All right. All right, let me have your attention back up here. And it's really interesting to me to listen to the different ideas, the different things going on. I wasn't able to hear this group, so can you guys tell me what you said? first one that pointed that out. So the blue is 1 times the absolute value of x. Notice it's up 1 over 1, up 1 over 1, up 1 over 1. The red is the 2 times the absolute value of x. Up 2 over 1, up 2 over 1, up 2 over 1. Let's go with the purple. The purple was 4 times the absolute value of x, right? Up 4 over 1, up 4 over 1. So Alex, you're right. What would your group say? Okay. Now, Sydney, I'll be very honest. I don't like the word smaller. Now, but you didn't know that. And a lot of people actually try to say smaller. But I don't know if you're meaning smaller this way or smaller this way. So that's why I try not to use the word smaller. So anybody raise your hand and give me a different word maybe that would mean exactly the same thing Sydney technically meant? Narrower. So we're going to use wider and narrower instead. Smaller is correct, but I'm not sure if she means horizontally or vertically. So we're going to go with narrower instead. Now, I want you to discuss in your group. Oh, if you didn't hit graph, go ahead. That way you can watch it go once. It's kind of fun to watch, isn't it? It's a lot faster on yours than mine. Mine, you have to remember, it's also hooked to the computer, so it has to run all of the program behind it. Now, I want you to discuss with your group what would happen if instead of me putting 1, 2, 3, 4 in, I use 1/2, 1/4, 1/10, and 1/100. Discuss with your group, but don't do it. Discuss with your group. All right. Let me have your attention back up here. Now, I told you not to do anything with your calculator. Now, while you were discussing, I purposely changed mine so we could see if you were right or you were wrong. Does anybody know what you actually just did in scientific terms? Kind of ish. You got to use part of the scientific method. We didn't do the entire scientific method. We did the hypothesis part of it, right? So you just came up with the hypothesis, right? I'm going to hit graph on mine, and we're going to see if your hypothesis was correct. Now, I like the little symbol. Shane's actually back there going like, that's actually a good thing. Actually, just so you know, Shane, that's actually called kinesthetic learning. That means he's not only just seeing it, hearing it, he's also actually doing it physically. So that's actually good. We hit all 3 modalities, which means we will definitely be remembering this. Okay? So yes, Shane's right. It does get wide. Make sense? Okay. So now, we figured out what happens if the number's bigger. It gets narrower. And if it's smaller than 1, it gets wider. I want you to make a hypothesis about this. What do you think is going to happen if I put a +1, a +3, and a +5 inside my absolute value? So take a minute, discuss with your group again. Come up with a hypothesis. No. No, good question. Don't do anything in the calculator yet. Come up with a hypothesis first. All right. You guys have a hypothesis? Okay. So I'm going to listen. What does your group say? Say it. Okay, where do you think it'll, or what do you think it'll do? Where? Take a guess. It's okay. Okay, so he's thinking it's going to move up on the y-axis, right? actually come up with a hypothesis. Now, we'll test it here in a minute, okay? And then we'll actually come up with a new hypothesis or a new correction to it, which means we're actually doing the entire scientific method at that point. What's your group say? Okay, so Brayden, you said you think it's going to move up one, and Alec, you're thinking it's going to move to the right. Okay, did your group say anything different? Be honest, did you? You were turning your hand sideways. Is that you think?
Well, I was thinking it'd be like this, but probably not.
Okay, so you're thinking, Mackenzie's thinking maybe it's going to turn slightly sideways. It's a good thought. Okay, she's all like worried, like, did I do something wrong? No, you're hypothesizing. There is that possibility of having a stupid answer, okay? And a stupid answer here would be, it makes a triangle. No, you already know it's going to make a V. We just don't know what way that V is going to be, right? Or it's going to make a circle. So that's a good hypothesis using what you've already known. You guys say anything different? How about you guys? Okay, so let's type them in. Let's see what it looks like. 1, 3, and 5. 1, 3, and 5. So I'm going to go down here. I'm going to clear my other 3. Math, num, ABS. Oh, I already did that one. Math, num, ABS, x plus 1. Notice the 1, 3, and 5, by the way, should be inside those absolute value signs. Math, num, x plus 3. Math, num, x plus 5. You guys are quick to use calculators. You like finding out these little things, don't you? So 1, 3, and 5. And I think we have 3 hypotheses in here so far, where Brayden said moves up, where Alex said it would move to the right, and where Mackenzie said maybe it's going to turn sideways. So let's see. Are you ready? Graph. The original graph. I always like to look at the original. Absolute value of x in blue. Red. X plus 1. Oh. Interesting. X plus 3. Pretty cool. And x plus 5. Huh. Now, which way did it move? Yes, Beyonce, that is correct. It moved to the left. That makes me very happy right there. Yes, it did move to the left. So if it's a plus inside, it moves it to the left. So, hypothesizing, if it was a minus sign, it would move it to the right. That's correct. Okay? What about a plus on the outside? What do you think would happen there? It does move it up. And a minus on the outside moves it down. Okay? Now, we're going to look at that. We're going to put that into actually even more simpler terms here in just a second. But at this time, you can... That's if it's a minus sign inside. If it's a minus sign, then it moves it right. But there is no way, Mackenzie, for it to actually turn sideways. Okay? But that was a good hypothesis. It was a good hypothesis. All right. At this time, you can put your calculators down. Because in this class, I think it's not only important to be able to use the calculator, but to do stuff by hand, right? So I'm going to show you now how to do it by hand. Very simply. Are you ready? Here is our problem. Go ahead and write down the equation beside the next graph. Write the equation beside the next graph. And we're going to break this up into different pieces. Okay. The very first piece that you're always going to tell me is the vertex. Ooh, wow, okay, let's, there we go, vertex. Okay, now that vertex is the starting point of the V. the starting point of the V. Now, if it was since it's -2, that's actually going to move it where? To the right. And the +1 will move it up. Okay. So, if I move to the right 2, that's a +2, right? And the 1 will stay the same. Now, Holden Martin actually made a point, and he said to me, Izzy, look at this. Another thing in math that just switches on us, right? Another thing, look, they don't use a minus, they use a +2 when they write the vertex. Another thing they switch on us. Well, understanding switch the sign of what's inside, keep the sign of what's outside, will help us when we do quadratics, will help us when we also do square root grafting here. And the process will be the same every single time. So, in fact, it's something that's going to stay the same. And you're going to hear me sing this quite a bit, or rhyme it, or whatever, where I say to you, switch the sign of what's inside, keep the sign of what's outside. I'll repeat that one more time while you write it down. Switch the sign of what's inside, keep the sign of what's outside. Kind of fun to say. Switch the sign of what's inside, keep the sign of what's outside. Being laughed at now because can't blame you. But you know what? At least if you can laugh at me and giggle at me, maybe you'll remember it, right? You'll be like, that teacher's weird. What? Oh my golly, on a test I actually remember that. So I honestly try to be weird. I know. So I switch the sign of what's inside, keep the sign of what's outside. Okay. Please, whatever you do, don't tell other teachers what I do this year.
Me too. Don't do anything.
I won't lie, I love teaching, so I figured I can always sing and dance in front of students and all they can do is giggle at me. They can't pull me off the stage. Okay, so which way does this open? Which way do you think it would be? Is this going to be a regular V or do you think it's going to be an upside down V? Why? Yes. In fact, this right here actually tells me it's going to be a down V. And then we talked about the words wider or narrower. Okay? And remember, 1, 2, 3, 4 was wider, where 0.25 was I'm sorry, 1, 2, 3, 4 was narrower, where 0.25 was wider, right? But what would -2 be? Actually, narrower. Because that negative on there only tells me it goes down. The 2 is what tells me whether it's wider or narrow. Does that help? Okay. So in this case, we're going to say narrower. And now we're going to graph it. Are you ready? We go over to 2 and up to 1 and we put a dot. And then we use our slope. What is our slope of this one? -2/1, right? I'd go down 2 and over 1. Down 2, over 1. Down 2, over 1. Down 2, over 1. Down 2, over 1. I don't want this just to be a small V in like the middle of your graph. So use it the entire way down, or pretty close to the entire way down. Now, it has to make a V because it's an absolute value, right? Letter V. I had Sydney just look at me like, what is wrong with that teacher? Purposely did that, Miss Sydney, just so you know. So, I need to mirror it on the other side. So I'm going to go down 2 and over 1 on the other side so that I mirrored it. Now it looks like a V, doesn't it? And I'm going to connect it. There. And there. And that's it. Pretty easy to graph, aren't they? I told you I like these. Yes, I would, Noah. If there's no, like if there was just an X inside here, then this would be 2 comma 0. Let's say the negative 2 wasn't there. Then it'd be 0 comma 1. Okay? Good question. All right, well, let's go the opposite way. It's important in here to not only be able to graph, but to write the equation. So I want you to draw this graph. And notice I'm putting these 3 points on. Make sure you put those 3 points on your graph. And we're going to write the equation of that absolute value in just a second. So I need to write the equation. Well, what 2 pieces do I need for an equation? Raise your hand to give me one. Noah. I need the slope. Okay? Which I'm going to call M, but it could also be the letter A. Because the equation uses the letter A, but I like M because slope is M. I wonder what the slope is. Look at it for a minute, think about it. All right, Cullen, I'm going to see if you are the first one today to get it. Let's check. If I go down 3 over 1, down 3 over... Oh, I didn't end on that point. A lot of people today have tried to give me negative 3, which is honestly why I put these points in to help us out. And I'll make sure you always have these points so you can always count. Yes, yes. Negative 4, I think, puts us down a little too far. Negative 3.5 is right, but I actually don't like that. I know, you're thinking, well, why? It's correct. Because I like the fraction. How far down do I go? And how far over? 2. So the slope is negative 7 over 2. That's the easiest thing to do. Just count. Okay, count from dots to other dots. Okay, what else do I need? I'm sorry, Sydney? That is correct. Make sure you raise your hand, Dom. She had her hand up. I wanted to make sure I got her answer there. That is correct. What's the vertex? Somebody that's not talked yet. Yes, what is it in this case, Jake? 3, 7 is correct. And guess what? I have all the pieces I need. I'm going to do it now. Are you ready? Y equals. What do I put first? The slope. Absolute value x. That's what? Alice? Minus 3 is right. Remember, switch the sign of what's inside. Okay, I'll say the other part. Keep the sign of what's outside. Jake? Plus 7 is right. That's how I write the equation. Uh-huh. I'm not kidding, Dom. This is meant to be an easy day. Okay. I told you, yeah, I know. That's why I was like, you need an easy day, right? Well, I don't want to just give you the essential work right now. We're going to do 2 more problems. One like the first one like the second one. We get those, we'll give you the homework. Sound good? So here's your first one to graph. Are you ready to graph it? Let's check. Let's pick on people that haven't tried. Sabrina, what's the vertex? That's perfect, because she switched the sign of what's inside. She kept the sign of what's outside. I told you you're going to hear that a lot, didn't I? I was right on there. Let's pick Katie. Katie, what's the slope? The number in front. There you go, 3 is right. So up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. I'm going to do that on the other side also. And make my V. Ta-da. No. I don't do absolute value inequality. You could do that, but we're not going to. With the parabolas we do. All right. Last problem. Graph it and write the equation. So, here we go. What is my slope, Jake? Negative 1/3 is right. Notice it does go down, so it has to be negative. Okay. What's my vertex before I actually do any of this work? somebody other than Jake this time. Jake. 5-2. I'm sure the people at home are like, wait a second, you said somebody other than Jake. That is a different Jake, people at home. It's a different Jake. 5-2. All right. You got to tell them at home, right? All right. Sammy, what am I going to write for the inside part? That's perfect. Wait, watch this. Sammy, what am I writing for the outside part? +2. People at home, by the way, that's two different Sammys. All right. Done. Essential work on a clean sheet of graph paper. On a clean sheet of graph paper. These 6 lovely problems due Monday. You have the answer key for them.